Okay. All right. For people joining this live stream, we are looking at new features in, oh, somebody needs to mute themselves there. We are looking at new features in graphs and number theory. Okay. Interesting combination for 12.1. Let's see roughly what we have to do here. All right. Let's start off. By the way, I have been using the graph theory stuff, as Charles knows, and it's basically working really quite well. So that's good. Hey, Charles can tell me one thing.
Have you been using the 12.1 stuff?
Yes, yes.
Good. How come?
What's that?
How come?
I've been doing all kinds of cool things, trying to figure out the universe.
There is that.
I'll show you an example of something just to provide context of some kind. Let me see whether I can find something here. Let's see. That's a Groen hypergraph. And so I wrote some code for making hypergraphs. This is an ordered hypergraph. It's kind of pulls out combinations of vertices and polygonalizes them like this. And one thing, by the way, I need to know, Charles, is the graph embedding function. What is the, how do I get the 3D embedding? Oh, yeah, I know that. I figured that out. Sorry, it's just the second argument of graph embedding.
Yes.
But I mean, I've also been doing stuff with all kinds of tagging and so on. So it's I'm so far so good.
I think we completely looked at the tagged graph stuff last time.
Remind me what tagged graph is again. Remind me what it is.
So it the name is edge tag graph actually.
Yeah, we changed it last time.
Edge tagged graph.
Yeah.
Right. Exactly. Right. Actually, we should probably be using this for some of the things we're doing. Directed edge with tag. Okay. Directed edge new. Can I look at it here?
Actually, just directed edge is already in the system.
Yeah, the new stuff should never build. I mean, the
yeah. Okay, fine.
It's just,
so what are you showing here? Okay, this is represented directed edge with that tag. That's wonderful. Yeah, actually, I need to make sure that Maxime, who's working on this hypergraph stuff, knows about this. Is there any PM person here? Nope. Okay, it's just us. All right, then I am going to screen capture that and do something very primitive here. Okay, all right. Annotations, have we looked at this?
We did not, but this is the design that we agreed on with, when we had several big meetings.
Yeah, I remember that. And do you think it's working okay?
Yeah.
Okay.
I think that there is still more experience to be gotten as we add annotations to more kinds of objects. But that's something that we will have to learn as we grow, grow into other domains.
Sorry, what were you just saying? By the way,
as we add support for annotations to other objects, I think that there is more things to learn. But we kind of have to learn that as we do those growing into those domains.
Yeah. Oh, that's an interesting point from Sandra on our live stream. A lot of code uses first and last on directed edge to get the beginning and end points of an edge. Ouch.
Well, shouldn't be doing that. I mean, that's not the syntax or the recommended way.
What is the recommended way? What is the recommended way of getting the start point and the end point of an edge?
But normally, an edge doesn't have per se, undirected edge or directed edge doesn't have per se start or end point. Normally, you should just take the first two value.
No, I'm sorry. In a directed edge, I have a directed edge. Okay. How do I get the beginning of the directed edge?
So it's UV. So you take the first and the second one.
No. Somebody will take, look, whether it's the first and second or first and last, they're both hacky. I mean, that's both a bit, they're both a bit hacky, right?
Right. So we can introduce a function to return it. That's one.
Or a sub-value for directed edge, possibly. Does that make any sense? Are we doing that for graphs at this point?
No.
No.
What would we call it? I mean, it would be nicer to look in the piece of code that says, has a fold list of, folding across across edges to see the thing say, beginning of edge, end of edge, or whatever it is. How would we do that? By the way, this particular point about directed edge of last of directed edge, we should absolutely tell people to look for that because it will indeed break code. Right? So what is our mechanism for getting people to do that?
Well, right now we don't have one. We can introduce, like you say, maybe a sub-value, maybe a function to do that, to return the vertex associated to an edge. So we can still
No. That's not what I'm saying to you. What I'm saying to you is, how do we communicate to users this change might break your code? Do you understand what I'm saying?
Yes.
Okay. I think that's a separate thing. Let's talk about it in the roadmap meeting the next roadmap meeting. Okay. I think we actually have one coming up right after this. So let's talk about that there. Okay. Can you bring that, or do I have to send a note to get that to happen? I have to send a note to get that to happen. We really need a project manager in these meetings. This doesn't make sense. Okay. What are we going to do about this?
I mean, it will not affect unless you use tagged edges. If you use a normal graph, directed, undirected, weighted, everything is as normal. Tags are only for multigraphs.
Right. So normally, if you have existing code, it will not break your existing code.
That's a good point. That is a good point. That is a good point. That's the point to make. Okay, 3-argument form, another comment from the live stream. 3-argument form of undirected edge. No longer canonicalize undirected edges using sort.
What?
The point is, if you have an undirected edge, how do you canonicalize the undirected edge? In other words, if you say undirected edge of
it's a question of whether two undirected edges are equal.
Yes.
That's why you want this.
Well, it's the old issue of that normally undirected edge should be orderless, right? But we don't really want the orderless of the system because it will, by default, sort the argument as soon as you evaluate undirected
well,
edge.
And now it certainly can't be orderless.
Exactly.
Well, not pure orderless.
Yes, so not pure orderless. So that was one option we need to do, as well as there's always also several of those issues that the pattern match would not directly map them, right? Because it doesn't know that they are orderless and things don't coincide. So
this is a problem. I mean, okay, how do we? I mean, it would be annoying to have to provide something called sort edges, right? What's the right way to do this?
but the key point is first the workflow. Why do you want to sort edges, right? I mean, there is several other ways to do that. Sorting is not necessarily the right way.
Well, what is the right way?
It depends on the goal or what the person wants to achieve. That's
Well,
kind of
let's
what
say they've got a bunch of undirected edges that were produced somehow, and they want to, merge them. Let's say. See what I'm saying?
Merged.
But
if
so let's say I say
if you build the graph, all that will be done first of all, right?
Well, and one crucial thing, especially for edge, directed edge, undirected edge, is that we try to preserve the order you give it as you construct it that way, right? When you do edge lists, we don't even sort them, right? And when you generate them from, for example, find cycle, right? We try to keep that that sequence of edges so that you have visually, if you take first of them, you have a pattern. So there's that whole consistency we preserve, which are quite useful.
What does that mean? What I just got there. So in that cycle,
you have B to A, A to B.
But if I'd done the graph ABAB, I would still have, okay, so I do that, and now I say find cycle of that.
Right. Because we want to return the path.
Well, that's interesting because those are uncanonicalized. That's a good argument for not sorting the undirected edge, right?
Yes, that was one of the reasons. And also we were thinking that, in our long-term plan, we have the tag, which was also coming. So that was all that we decided that we shouldn't do.
So if I put a tag here, why is it turning red?
Oh, with the front end, we have to update all the things. Not yet done.
Why? Okay, so if I say show that graph with vertex labels true, how do I get it to also show the tags?
I mean edge labels, right?
Eligible.
I see. So if I say edge labels, arrow automatic. Oops. You need to put automatic in there, right?
Yes.
No. What happened there? That's a goof.
And am I missing something? What do you mean?
Look at the labels. The labels are bonkers. See those labels? This is a tagged edge, right? Charles?
Yes.
Why isn't it? I want the tag as the label on the edge.
Oh, right. We haven't introduced a name that, but automatic behaves the same as the vertex label. Automatic means the name, the actual object.
Okay, but okay. How do I put the tags as the labels?
We haven't yet thought about it.
Oh, for goodness sake. I think automatic should put the tags as the labels if it has tags.
And if it doesn't have tags? I mean,
I don't think it should ever do this. I think this is really weird. I mean, you could maybe say all or something to do this if you want to. This is weird. If it has tags, use the tags.
I mean, when you deal with non-tag edge in that whole sample graph, all this makes sense. Edge label, automatic, you want to look at, what corresponding edge and doing stuff. Right? We shouldn't forget that side too. Because
sorry, if you want to do what?
I say usually when, you generate a graph, which is a sample graph, you don't have multiple edges or tags, right? And you want to do an edge label, you just want to see the name of the edge. Right? Automatic makes sense, and we never had that issue.
Sorry, what do you do when you have the name? What is the name of the edge if it isn't the tag?
The
So
name of the
if you do complete graph 5, edge goes to automatic. Right? Sometimes you want to manipulate and just look at the edges.
So for if you want to set annotations and other things, the name of the edge is just that. A undirected edge AB. That is the full name.
Okay, that's interesting. That doesn't look bad, actually. That looks better than I might have thought. Okay, but if there is a tag, surely automatic should just put the tag there.
Okay, we can do that.
But I would do all or something, or true, edge labels to true should do this. See what I'm saying?
That's incompatible change then.
Why? What does true do right now?
No, I'm just saying that this is what automatic has been doing.
What?
What you're just seeing.
But not for tagged edges, because we haven't had tagged edges.
Fine.
Well, in principle, actually, we had tag edge since the first release. We just haven't documented them, activate them, because there is that whole thing we needed to build and make sure they work.
The fact that the thing is turning red means we can ask people on our live stream whether they've ever used tagged edges. But
no, that's what we said. No, that's not what he said, and it's not what we meant.
So what are you saying about? So I think we should make edge labels to automatic show the tags if there are tags. Okay. If there aren't tags, you've got to do this whole thing here. I would do edge labels either to true or to all, doing this behavior here. Right? Okay, question. I just did a let's see. Okay, now it was claimed that this doesn't work if I publish this to the cloud. What's going on here? Have you checked this?
For the cloud, well, we did that. I don't know, version a while ago. I mean,
yeah, a long time ago.
No, so this is not a live. Oh yeah, it is. Okay, it just during rotation it doesn't show. So that works. So somebody on the live stream is complaining this doesn't work, but I think it does work. It just, the preview image, and that's an issue that I just asked John Paisley to look at, is the way preview images work for complex graphics in 3D. But that seems to be working fine.
I think that WebGL implementation is quite limited that does the live stuff.
I understand, but he should just put, instead of tubes, he should put lines there. That's just a glitch. Okay, question from the live stream about breadth first and depth first search, and complaining that they were horrible functions to use. Okay, I don't have an opinion about that. I've never used them.
Well, I mean, Roger can say probably more there too. Those are general. I mean, we made them too general, and at some point, we plan to build, more simpler specifications. Yeah. So it's.
I mean, this is the full generality. The problem is that what you often need is something simpler. Rarely do you need this level of generality.
So let me ask a question. So one of the things that's coming up from what I'm doing graph rewrites. The question is, what's the updating order in a graph rewrite? Does this provide me? No, this does not, because this is pure depth first scan. Is that right? Or what does that even mean?
That's exactly what it means.
Yep, exactly.
But I mean, does that mean that there's only one updating order that I get here? That means there's only one visiting order that I get.
Yeah.
Well, there is also, what was that? We have the ability that you can actually slightly control the visiting order at some point.
I mean, the fact is, this idea of look around as you're visiting, we don't even have it for map. You know what I'm saying?
Right.
So what is the analog of map for doing something to a graph? So let's say I want to take the graph and I want to look at every neighborhood in the graph and I want to do something to every neighborhood in the graph, which to me would be an obvious kind of thing to do. I want to look at every, go ahead.
And it's a state change between them. It's not, so map is completely parallel. There's no state change happening.
Absolutely. So what I'm saying is, imagine I have a graph and I want to visit every node, inspect its local neighborhood, and decide what to do. And build a new structure based, so what map would do is it would essentially insert something into, it puts a function. So I don't know exactly how that works here, because what's odd about this as compared to map is map descends the tree and locally looks at a subtree, and all it knows is the subtree it's looking at, right? Now, for a graph, all nodes are equal in some sense, so there is no obvious subtree you're looking at. And it's not the case that you can just take a function and apply it to some subgraph and expect things to, glue together correctly. Did that make sense?
Yes.
So I don't know, what is a typical application here of this depth-first scan? These are all side effects, what you're showing here.
It's a scan function, so everything you do is going to be side effects.
Okay, so my question is there a map function that goes along with this?
No.
Should there be?
I don't.
Possible if it's useful. So far I haven't yet seen cases.
Right, so if what everybody is doing is a reap and a sow on this, yeah, it would be interesting to see some cases of this. Okay, what's the analog of, you collect data from every local neighborhood. See, the thing I'm confused by, let's imagine that you have a function which is given the graph centered on a particular node. Yeah, it's just very unclear what this should do. Okay, so responding to Ethan on our live stream, the statement they were horrible functions to use, tell us something you would like to do with them. Because other than sort of exercises, I'm not sure what people, you tell me. The fact that there's so few, this function is kind of a joke, because look at how long its description is and look at how few examples it has. Right, that kind of tells you something right there.
That's strange, because normally it have more than that. Something is
not right.
Not right, because one standard application, maybe the depth first, something is missing in depth first. We have breadth first. Like to compute connectivity. I will say 50% of graph algorithm are traversals, right? And it's essentially that. So we provide that depth first interface to user if you want to build more algorithm, right? So if you want to build your own version of connected graph queue, right, you can just use depth first. And
by the way, I assume you're going to edit all these property value things, right?
Yes.
Well, this looks like it has lots of juicy stuff. I don't understand the packaging of these functions. It seems like a very interesting exercise to try and understand this better, but I haven't, and I don't know what the patterns. Looking at these examples, can you see any pattern that you could package differently?
Yeah, there's some basic cases where, usually people want, explicitly the list of vertex, visited vertices and such, where we can provide those functions instead of having complex callback function. And this is just essentially too general, but it covers all the possible cases.
Well, maybe what you want to suggest something, given that this is just doing a scan, right? It is basically generating an ordering of the graph, right?
Yes, if you look at the vertices, yes.
Okay. So in a sense, one way to do it would be to just say, you know, one thing that seems useful is just a thing that says, you know, breadth first vertex list.
Yes.
That would be a useful function. And I would recommend it.
Which is, I believe, the return value of this function.
But I've got to give all this other crud as well.
Well, I think if you don't give anything, you actually just get it by default.
Okay, so if I say like this, okay, well, if I might say so, where the heck is that? Right? How about putting that as the very, very first usage thing there?
Yep.
And then the very, very first example before you get to any of these other weird things with pre-visits and so on. Make sense? By the way, you should probably use echo there, but whatever. I mean, that seems useful to me. Because then I can just go in and do whatever I want and, you know, find whatever. And I don't understand quite what this is otherwise doing for me that I couldn't do given that list. Do you understand my point?
Yes. Right. But I mean, when you want to implement certain type of algorithm, you know, you need to actually know the state of the traversal. If you, for example, want to check that a graph is connected, if you do a depth first and then you find that, you know, at a certain stage, or you want to detect cycle, right? You can easily exit by knowing that you encounter a pre-visited vertices.
Okay.
So it's those states which are quite useful.
Okay, can I ask you, can you confirm you're going to put as the very first thing here, breadth first scan of G returns the list of vertices in a breadth first order, breadth first scan order. Okay. Yep. That will help a lot. Will help something. And I would like to, I think it would be interesting to look at that some more. Okay. Okay, I'm looking at some of these comments here. Ethan is commenting on we should be able to tag vertices as well as edges. No, that's not. I mean, you can do whatever you want in a vertex. You can call a vertex anything you want. You can have all kinds of data in the quotes name of the vertex, right?
Either in the name or as an annotation. Probably more sensible as an annotation.
Right. Okay. All right. Let's keep going here. I would really like to. I'm sorry. I feel that we could be making a mistake here. I would really like to see some examples with these things, just to make sure we're not goofing something up. Do you have do we have some real examples here yet?
Well, we try to put some basic example. If you open, I think if you use the docu tool.
Okay. I'm going to try to use these. I'm concerned because I feel what does that mean? Annotation names are just a generic graph? What does that mean? So if I say this, okay, and then I say annotation names. Okay, what does that mean? What the heck is that?
Those are named annotations, and those happen to be standard annotations, also known as options. But those are treated as annotations that are standardly supported.
Okay, so if I want to annotate,
those are not custom ones, those are standard ones.
I understand. Okay, so let's say I want to annotate, I want to turn red. Let me do a random graph here, okay? Okay, now I want to turn red all vertices with numbers below 10. How do I do that?
Vertex style.
How do I do it with annotations?
I/dot. Well, you can set. You can use the value and just set it.
Okay, how do I do that?
So you can do annotation value. Everything work. Annotation value of.
Yeah.
Let's
So
try
let's call
one
this
case.
graph. Let's call this graph GG. Okay. Annotation value of GG. Yep.
Or let's just say, in a list G, 1, just for simplicity.
In a list.
In a list. And let's just use it as a comma vertex style.
Okay, why didn't that have a caret if it needs 2 arguments? That's a bug.
Well, there is a general case. And there's a general case. No, that's a bug. Right.
That's a bug. Yep. Okay, what's next here?
Vertex style.
Okay.
So you can
So now I can say equals red. Is that right?
Yes.
Okay, now if I say GG again, God, that's weird. Okay.
So what this allows you to do is actually real-time algorithm animation, among other things. If you want to show something traversing a graph or building up a graph in real time.
Yeah, this is nice.
That can be done.
Of course, we don't have.
It can't be done.
We don't have for graphics.
But we do have it for graphs.
Yeah. Okay.
But the thing we don't have for graphics is we don't have a scene graph. We don't have the addressability.
No, I understand. Is this nice and fast?
Yeah.
Yes.
But you need. I think you want to have it.
Seem to work fine.
Yeah.
No, since it's the symbol, so.
If you do a little pause there, you would see them change. Do you know what I'm saying? It's going to be too fast now, but if you want to be able to follow it at human speed.
Yeah, I understand.
Pausing like 0.2 seconds.
Okay, so if I say in here, do that, but then I want to say dynamic of GG.
Exactly.
Pause
0.2 or something.
Well, I can't see a damn thing happening. If anything's happening, I can't see it. How do I do, if I say vertex style, vertex size, what is the units of that?
So if you put a value there, is roughly is the nearest, right? So
if I say 3, will they be big?
Should.
That's very cool. That was very cool. Very nice.
And that becomes quite powerful when you want to see traversals following something or build up. If you search and you see how a frontier of edges evolve, for instance.
Yeah, I like that a lot. Ethan on live stream is saying that annotations versus tags should be made clearer. What is the difference between an annotation and a tag? So if I want to put in here, if I say annotation of GG, 5, fishiness.
You mean annotate, right?
Or annotation value.
Right.
A fishiness equals false. Right? And now I want to say annotation. Now I can retrieve annotation value of GG5. Is that right?
Yeah. But you need to say which annotation.
Right. So that's.
There can be many.
Is there an all?
No.
There should be. with an association, returning an association. Cool. So syntax, coloring, and an all with an association. Makes sense?
Yes.
I'd like to play with this some more. So what does annotate do? Is annotate the same thing as saying annotation value equals?
Yeah, roughly speaking.
Or what's the difference?
No, it doesn't do that. It's like a wrapper. It sits.
No, annotate. Annotation is the wrapper, right?
Oh, right. Okay.
What's the difference between annotation value equals and annotate? Or is annotate the same as annotation value equals?
Theoretically, they are the same, but in annotate value, the L value is more efficient since you have the symbol and you're changing it in place in some cases. But
I see. So this case, so if I were to say here, if I were to say annotate GG, wow, this is kind of weird. Name our, oh, I see, annotate GG5, and then I say vertex size arrow 5, for example, right?
yes, then you get the graph actually.
Then I get the graph back, but GG is unchanged.
Yes.
Nice. Okay, makes sense. Is that explained properly somewhere?
Well, I think we have a line in annotation value where we say
Not good enough.
value.
I think we should have something in the guide page. We should make sure that we explain this. And we make sure that we explain that annotation value can be an L value in the guide page.
Guide page or reference page?
Well, both. But I mean, we should show annotation value as an early example with annotation value as an L value. Right?
Yes.
Okay. Graph constructors. So expression graph, what is this? This is like, so how does this relate to the trees business? This is compatible with the trees business because we're going to have a separate expression tree thing. Do you know how Tony's project on trees is going?
Well, I talked to Jose, right? So he probably told me that since last time there was pretty much no progress until I think Tony's coming back or such a thing. So
I'm sorry, what?
Jose told me essentially, I think the last meeting we have last year, nothing had been done on that project.
Last year? What are you talking about? Okay, Tony is now actively supposed to be working on that project. Are you telling me that your recent information is that that's not happening?
Or he haven't yet get back to it. I don't think I noticed anything.
Okay, then I have to go chase it. Let me send mail.
If my information is accurate.
I hope it isn't, because I was told that it was actively being worked on. Since we don't have a project manager here, nobody can go check. Okay. So what is this? So this is
to support of entity in graph.
So this, why isn't, oh, I see the entity. Oh, that's nice. That's really nice. So if I say graph of control equals, I don't know, butterfly graph. Is there a butterfly graph?
Yes.
Cool.
Or edge count. I mean, the whole full functionality handle it. So
I see. So if I were to say, for example, here, vertex list is probably something, well, let's try, I see. So there's a bunch of things in here. Well, let me point out that this is not a useful page, right? You should be saying something. You should be using graph here, right?
Basic application, if you.
Well, okay. So it should be in basic examples that you can see something other than just how to get to, you know what I'm saying? Right? You should have something in basic. Since you know basic applications isn't open by default, you should put something above the fold. Okay, so I don't quite understand why that. What the heck? What the heck is that?
It's a failure in quantity framework, something.
Yeah, I understand that. But why is this resource data is not the graph? Why did you choose to make the default element not the graph itself?
No, if that's the summary, which is the second argument.
Oh. So that is the graph itself.
Yes, and it's big, so we return the blob for the time.
Okay. Now, what are we doing with showing, being able to make summaries of very big graphs, visual summaries of very big graphs?
I think the closest we have is what you're looking at now. That's a summary blurb, and you can open that plus sign and you get the more summary statistics.
No. I'm talking about a visual summary of the structure of this graph, like zoomed out. Like if I wasn't going to actually render the whole thing, like in the case of this particular graph, you know, I'm sure if I actually render it, can I do that by just saying graph of that?
No.
Probably graph plot. Supposed to try to do that.
Okay, so if I take this, I'll get some big messy thing, right?
Yes.
Okay, so my question is, what we want to do, like, you know, if you use an interactive graph viewer and you are zooming out a long way, right? It's not showing you every node. You know what I'm saying?
Yes.
So what is our idea for how to downsample this? Is there some obvious algorithmic way to downsample the graph and then get, you know, essentially a summary like this? What would happen in an interactive graph viewer if we were looking at this? We would get some kind of summary of this, right?
Right, yes. Alice,
how does the summary work?
Well, I think it's most of the time it's a matter of structure you want to show, right?
I'm not sure that there are such summaries. You know, because normally you zoomed in and then you have an overview, which is a navigation window in one of the corners that allows you.
Okay, where's the overview coming from? I mean, in other words, are you rendering? Look, at some point, does one compute every piece of the graph or not, is the question. So it could be, if you look at this, there's a certain rendering time and there's a certain computation time. How does that break down?
Oh, you mean for this specific case? I mean, if you
put a big graph. How does it break down? Go ahead.
If you put a semi-comma to the graph plot, right, we actually in code generate the graphics, right, and then you will not render, right?
Yes.
So in terms of that's fast. That should be fast.
Okay, so if I say %41, if I say absolute time. Okay.
What is %41?
It's the same graph. 16,000 nodes.
121,000 edges.
Oh.
20 seconds.
Well,
I don't think it took much longer to do.
Well, normally it should be actually below that. It should be in less than a second. There's probably more at the analysis you are doing yet on those large graphs. But in principle, like Spring Electrical and such should be pretty fast on those.
Okay.
It's when we plan to render it, we first, try to
Okay,
analyze the
so
function
then
structure.
there could be a version of graph plot which has some kind of coarse graining, downsampling, which doesn't then render every node. It knows essentially the density of nodes on the screen. Because like rendering every node in here is a waste of time, right?
Yes.
Yeah.
So how could we do that?
We did spend some time thinking about that early on, but it's I don't think we have a viable such plan or model at this point.
Yes.
But yes, it has come up, and we have spent some time thinking about it.
Yes. I'm sure we can find several things, especially like the case of the high-dimensional embedding, which is essentially the spring electrical in high dimension. So essentially, you do those several layers. Right? So at one layer, you can actually show this roughly a view of the graph until we zoom down, and then we return it. So
well, I think that look, with all these things, I think it not only needs sort of an idea, but also experimentation, because visual stuff without checking it. I mean, you could imagine if something is strongly connected or something like that, it gets rendered as a node, as a blob.
Sure.
Because there's nothing to say. Everything is connected. You don't really need to know the details until you decide to drill down.
Yes. There's also other view where you can use, like what we have community graph plot, right? Community, you blob them, and then you have a hierarchical view of your graph.
Sure, right. But that is still showing every node, and you don't need to do that.
Yes, so I say we can use the same scheme, but then just instead of showing those nodes, we just show one.
I think that would be a good idea. Can we look at that? I mean, okay.
But I think I kind of think that there's more than one idea here of, sort of visualization like that. It depends on what you want to stand out.
So this person, Maxime, is going to be working on a bunch of these graphs for the physics project.
Mm-hmm.
He would be a good person. He's a good software engineer. He would be a good person to look at some of these things. So Charles, you should make sure he's coming to the conference. You should make sure to talk to him about this stuff, okay? And maybe he can try and prototype some of these things, because I think he's going to need them anyway.
Sure.
Question from Ethan: can we get D3 styling primitives for sexier graph plot themes? I do not know what's there, but that seems like the kind of thing we should be able to do. Do we have a plot theme thing for graph?
We do.
Yes.
So,
but they're not considered sexy?
I think that they're sexy, yes. But it never hurts to look at what's there. I don't exactly know what D3 has.
Perhaps Tim or somebody should look at it. That looks kind of cool. That is cool. Yeah. Please make graphs compilation friendly. What does that mean?
Yeah, I don't know.
Well, doing operations on graphs, being able, but that's, I think, a question of, yeah, I'm not sure. Okay. Sander says, Vertex list of undirected edge could return the list. That is a good idea. Here's the idea. Simple idea, but that's a good idea. Why not have that return list AB? Seems like a good idea. Do you agree?
Yeah. I guess it could also then work on a list of those.
Yes, that's a good idea too. So Charles, thank you, Sander. That was a good idea. And Charles, can we implement that?
Sure.
Okay, and document it. I mean, it seems like an obvious way to do this. And then first and last would work on the vertex list of an undirected edge, which makes sense. Ethan is complaining that when you have a lot of large graphs in a notebook, frame rates grind to a halt. Why is that? Is there anything dynamic in these graphs? In a graph here, is that dynamic in some way?
No.
So why would Why would the front end grind to a halt?
We have to see the examples. If it's a big graph like that with millions, sure.
Well, it's not sure because the front end is maintaining a cache anyway, a bitmap cache of what's coming on that page.
It's worth looking at. I don't know why, but we looked at that to make sure if you have a notebook of many small graphs, it should be fast. I think that's something that I recall as specifically.
Yes.
Right.
Yeah, I mean, look, listen, I've got some notebooks with lots of graphs in them and they do fine. So I'm not quite sure what we're talking about here.
And they're purely graphics, actually. So we have to see example to,
Okay, fair enough. The complaint is that graphs are not allowed in function compile and NORA associations. Yeah, many more types will be rolling out there. Downsample working on graphs, I don't see how that would work.
Sorry, what?
Downsample working on graphs, I don't see how that would work because I don't know what a downsample really only works for adjacent things. You take 1 out of 5, but I don't know what that would do. I mean, I suppose you could make it work. You could decimate the graph, but I think that would just produce completely different results, wouldn't it?
Well, you should just do maybe subgraph of downsampling of vertices or edges. Edge list or vertex list.
Right. So you could just, I see. So you just do a downsample. So I mean, like in this graph, for example, if I did, that has 16,000 nodes. If I did %41, if I said subgraph of %41, comma, downsample of vertex list of %41, comma, let's say 50 times downsampling. Is that how downsample works? Is that how downsample works?
I think so, yeah.
I have to go look.
Cool. Worked fine, except what on earth is that blob at the bottom?
Oh, I do. Automatic vertex size should have probably.
Well, but also, what is that? That is a downsampled graph, so that's probably the big central cluster that sort of, I've never seen it do that. What a weird thing.
You have a lot of disconnected components.
Oh, you think those are disconnected components?
Yep.
So if you think if I downsample by a smaller factor, I'll see, oh, I see. Okay, that's weird. And the only issue here is that the size of the dots has gotten a bit out of control.
Yes.
But it's not obviously bad. I don't think that's a bad result. Yeah. Hey, here's another thing I was trying to do. I've got 2 graphs, and I want their vertices to be the same size. So I've got 2 graphs. They're in the same overall bounding box. It's graph A and graph B, and I want to compare the 2 of them, but I want their vertices to be the same size. And right now we're having to write a bunch of hacky code to make that happen. Any comments on that, Charles?
Vertex size go to scale coordinate doesn't work.
That's a good question. I don't know why that wouldn't work. Ask Max why that doesn't work. I don't know.
I will check that.
I mean, I'm pretty sure he will have tried that. Okay. All right. Onward here. All right. I as I say, I would really like to get some experience with these annotation things, and I will try to do that in the next week or so. All right. Obsolete the graph style symbol. All right, fine. Find maximum cut. Okay, comment from Lucas on the live stream about downsampling for graphs would be to group strongly connected components, strongly connected vertices into single ones. Oh, I see. Will all the outgoing edges be preserved? So in other words, if you've got like an area where it's basically a complete graph, just contract that.
Yeah, that's more or less what I said. I mean, if it's strongly connected within that component.
Right.
Or you can
You know
probably
what? If you suggest that to Maxime, he could probably implement that, and we can see what it's like.
We have the actually a rough Vertex replace actually does that contractions, but yes.
Well, how does that work?
Well, Vertex supposed to replace the vertices, but when two vertex identical, so if you replace, 1 by 2 and 2 by 2 again, then we try to do a contraction principle.
You don't say that.
Because
you do not say that.
Yes, and because in principle we should have a separate function to do that. Vertex replace should just preserve that bijection in terms of naming scheme.
Okay, but so if I take a complete graph and I say vertex replace in that, and I say table, I goes to 1, I up to I from 6 to 10, for example, are you saying that it will do? Oh, that's cool. Okay, so that's the beginning of that process. But could you mention this to Max? And I think he could make a prototype of this. Okay.
Yes.
Yes. Find the partition of a graph 2 with the maximum number of edges cut. Oh, that's good. What did you do here in terms of placing them correctly?
There's a ton of layouts, specialized layouts, as well as general ones. And in particular for the specialized ones, one can find an algorithmic criteria like these ones. If you look at below what the new one looked like, see?
Oh, I see.
And it's like that for many of them.
Wait. What's the difference? It's just they're a little bit closer.
No, they go outside. They know where the edges go, so they're not printing over the edge.
Oh, very nice. So if I say random graph, this is 12.1 that I'm running, right? Yeah, obviously. If I say random graph like 100, 200, and then I say vertex labels to automatic.
Is the top right position.
So that one isn't. Do you know what I'm saying? That's a general layout as opposed to a specialized layout.
Okay.
And now for this one, it needs to run a different and some kind of optimization algorithm if it's going to find better.
Yeah. And do we have any way to do that right now?
Yes, actually, roughly the same idea where, I mean,
is there anything I can run, or is it just something that's coming?
I would say something coming. I don't remember exactly what was the option we used since we didn't want to document it yet.
If there is one, could you tell it to Max, please? And he can play with it.
Okay.
For the stuff we're doing. Okay. Let's quickly look here. We probably don't really have time to go into this. Oh my gosh. Oh, this is mostly documentation changes. Is that correct?
Yeah, it's mostly examples, but also notes.
But also we have new implementation of PrimePy.
Yes.
Okay. So is it in the documentation here?
No, not we.
DocuTools.
So I say PrimePy new or PrimePy?
PrimePy new.
Lots of fancy methods. So how high can I get?
You can reach the known limit, which is 10 to the 30. Right. So that is the current version. We don't go be above 10 to the
So why
16.
isn't this is 12.1? So why am I running the new version?
Prototype build.
Oh, okay.
We haven't yet merged it.
Okay. Let me just see that just for fun. So the documentation changes, I'm sure, are great. That's a weird thing that slash is so big. Oh, that's probably just a problem in the source here. Whatever's happening in the 12.1 prototype. Oh, come on. Did it just crash? Well, that's what happens when you're running a prototype build. Fine, I can't see it. So sad. Oh, maybe it didn't crash. Who knows? Okay. So prime pi is new. That's wonderful.
As well as prime. And we get efficiency for random prime and related function.
So how far can prime go?
Pretty far. We just do a search for efficiency,
Oh, I see. We know prime pi, but so we can't get prime above the 10 to the 30th limit for prime pi, presumably.
Yes.
So we're doing some kind of binary search or something on prime pi to find the nth prime.
Yes, roughly speaking, yeah, the general algorithm, the standard one is that, yeah.
Cool. Okay. And do we have fine state-of-the-art algorithms for all these things now?
Yes, multi-threaded, all the fancy thing.
Oh, it's multi-threaded. That's cool. Huh. Okay. Okay. Anything particularly to look at here? I mean, I'd love to look at these in more detail, but is there anything particularly to see here? It's obviously a lot of work.
No, prime pi and prime pi new and prime new kind of have the two basic template in terms of documentation and stuff.
Okay, great. All right, I think that's probably everything for right now. I really look forward to playing around some more with this graph stuff and kind of checking the story. I'm still a little worried about the annotation stuff, although I think it's going to be okay. All right, anything else here? Okay. Thanks to folks on the live stream. Some good suggestions. Thank you for things like Sanders' vertex list suggestion. Very good. Much appreciated. All right. See you all soon.